Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover strength and materials in 6, the topic of this tutorial, helical springs, example 7.2. The question is included in the video. We have been asked to issue a cautionary note. When doing these questions, please use the method I am going to show you, as this is the method that is marked correct. Using your own method to answer questions could cost you marks even though your method and answer might be right. See the cautionary note at the beginning of the video. On a side note, watch till the end of the video. If you watch the first 5 minutes, you will not gain a full understanding of what you need to do. There is no quick fix in strength and materials. It takes persistence, discipline and repetition. You have to use these steps in order to succeed. Let's get straight into it. Okay, our question goes. A coil is compressed to its solid length of 60 millimeters by a force of 50 Newton. So, L solid is 0,06 meters by a force of 50 newtons. So, W equals 50 newtons. The shear stress in the coil at this compression is 125 megapascals. So, shear stress 125 times 10 to the 6. And the stiffness of the coil is 1 kilonewton meter. So, stiffness is 1 kilonewton meter. And finally, G is equal to 50 gigapascals. And G equals 50 times 10 to the 9. First things first, they want us to calculate the deflection of the coil, the strain energy in the coil, the diameter of the coil wire, the mean diameter of the coil, and the number of coils. So, first, deflection is very easy. Deflection is this symbol here. So deflection is W over S, which equals, so S is 1 kilonewton meter, and we're dealing with newtons. So it's 50, it's the weight, 50 over 1,000, which equals 50 millimeters. So, what we're going to do now is say that our deflection is 0,05 meters, because that'll be important later. Next, they want the strain energy. U is equal to 0,5 W times deflection. Okay, so 0,5 times 50 times 0,05 is equal to 1,25 joules. This will be important later. We will need our strain energy. Okay. Now we're going to find the diameter of the wire. First things first, we're going to say U equals times square root of 4G times volume of wire. So this is the basis which we will have to work off of. So now we can work with that. So we want the volume of the wire. So take 4G, take it up. So it's U4G over tau squared equals volume of wire. So now we have U 1,25 times 4 times 50 times 10 to the 9 over 125 times 10 to the 6. And this equals our answer of 1,6 times 10 to the negative 5 meters cubed. That is the volume of the wire. So, volume of wire is equal to 1,6 times 10 to the negative 5 meters cubed. So, next is we're going to find the volume of the wire itself. So now the volume of the wire, that formula. So we're given a different formula for volume of the wire. And the volume of the wire's formula is pi dn. So times pi small d squared over 4. Now this is equation 1. That's equation 1, which we will use near the end. Okay? Now we need to get equation 2, the number of coils. So the number of coils is N equals length of solid over D, over little d. So this equals 0,06 over d, over little d. So that is our second equation. Now our third equation, now we need to find the mean diameter. So the mean diameter is pi tau d cubed over 8w. Okay, so we have pi times 125 times 10 to the 9 d cubed over 8 times over 50. So this will equal 981,748 d cubed, which is big D. So now that is equation 3. So we take D equals 981,748 d cubed. Now we put all that into our first equation. We take equation 3 and equation 2 and sub it into equation 1. So it'll all look like pi times 981,748 d cubed times 0,06 over d times pi d squared over 4. That's how our equation looks. So now we have to get all the little d's and all the pi's together. So we have, d cubed times d squared is d to the 5, divided by d is d to the 4. So we have d to the 4. So, let's go. This is volume of the wire. So we have volume of the wire. So this is volume of the wire. And let's get that. Volume of wire equals pi times 981,748 d cubed times 0,06 over d times pi d squared over 4. Now we are looking for little d, which we can find now. So let's keep all the d's together. So we've got pi and pi. That goes under. So what we have now is volume of wire divided by pi divided by 981,748 times 0,06 and pi squared. And that's times 4. Okay. That is all our steps. So, I've done the pi's equals d to the power 4. Because that is done. That is done. The 0,6 is done. And the 4 is done. Yes, and the volume of the wire. So, now all we have to do is just put the volume of the wire in and divide everything, well, root everything. So, d to the power 4 is equal to 1,6 times 10 to the minus 5 times 4 divided by pi squared times 981,748 times 0,06. And this will equal what d to the power 4 is, but we don't want d to the power 4, we want just d. So that is cube rooted, well, fourth rooted, and d equals 3,24 millimeters. So small d is 3,24 millimeters. Alright, now they want the mean diameter of the coil. Well, that's easy. They want the mean diameter of the coil. That is easy because we've already worked that out. we've already got the mean diameter. Or the formula for the mean diameter, I mean. So, the mean diameter is big D equals 981,748 times 0,00324 cubed. And big D is equal to 33,39 millimeters. And now the next question is, question 5, is they just want the number of coils. So we've done that before. So our LS, so we can take both measurements because they're both in meters or millimeters. We need to take it in millimeters, so it's LS over little d. So if it's an LS, so that's 60 over 3,24. So the number of coils is 18,52 coils. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comment section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.